Apriori algorithm example, and there's the given transaction database and has minimum support too. Let's do the first scan. So in candidate number 1, there has a 5-item set. Item set A, B, C, D, and E. So let's determine how many A in transaction. We have 1, 2, 2. How many B in transaction? 1, 2, and 3. How many C in transaction? 1, 2, 3. How many D in transaction? 1. How many E in transaction? 1, 2, and 3. So let's see what are the frequent items. So let's prune D. Because D doesn't pass the minimum support, so the frequent item set is A, B, C, and E. A had 2, B has 3, C has 3, and E has 3. Let's do the second scan. So in candidate number 2, there has 6 items set. AB, AC, AE, BC, BE, and CE. So let's determine how many AB in transaction. So we have 1. How many AC in transaction? 1, 2. How many AE in transaction? 1. How many BC in transaction? 1, 2. How many BE in transaction? 1, 2, and 3. How many CE in transaction? 1 and 2. So let's see what are the frequent items. So let's prune AB and AE because it doesn't pass the minimum support, so the frequent item is AC, BC, BE, and CE. AC has 2, BC has 2, BE has 3, and CE has 2. So let's do the third scan. Has a one only item set, which is BCE. BCE. So let's determine how many BCE in transaction. So 1 and 2. So the frequent item set is BCE. BCE. This is association rules which have a minimum confidence 80%. The association rules is only based in the third candidate. So let's use B, C, and E, and B, E, and C, and C, E, and P. So how many BC in transaction? We have 1 and 2. So let's put the answer in the right side. How many E in BC. So we have 1 and 2. So how many BE in transaction? 1 and 2 and 3. So let's put the answer in the right side. So how many C in BE transaction? We have 1 and 2. So let's put the answer in the left side. And then how many CE in transaction? We have 1 and 2. So let's put the answer in the right side. How many B in CE? So we have 1 and 2. So let's do again reciprocal items, which is B and CE and C, B, E and E, B, C. How many B in transaction? We have 1, 2, and 3. So let's put the answer in the right side. How many CE in B? So we have 1 and 2. So let's put the answer in the left side. How many C in transaction? We have 1, 2, and 3. So let's put the answer in the right side. So how many BE in C? So we have 1 and 2. So let's put the answer in the left side. How many E in transaction? We have 1, 2, and 3. So let's put the answer in the right side. How many BC in E? So we have 1 and 2. So let's put the answer in the left side. So let's total. 2 divided by 2 is 100%. 2 divided by 3 is 75%. 2 divided by 2 is 100%. 2 divided by 3 is 75%. 2 divided by 3 is 75%. 2 divided by 3 is 75%. So let's do prune based on minimum confidence, which is 80%. So let's prune the BEC, the BCE, the CBE, and EBC. So the strong association rules is BCE and CEB because they pass the minimum confidence, which is 80%.
So this is the FP growth. So this is the given example or the given transaction table or the given transaction database. It has a minimum support 3. So before we find the frequent, let's do find all items. M O N K E Y D A U and I. So how many M in transaction? Here has 1, 2, 1, 2, and 3. How many O in transaction? There has only 4 O. How many N? There has 1, 2. How many K intersection? There has 5. How many E? 1, 2, 3, 4. How many Y? There has 1, 2, 3. How many D intersection? There has 1 D. How many A? There's 1 also A. U is 1. I is 1. So let's do pruning based on the minimum support tree. So let's prune N, let's prune D, A, U, and Y. So the frequent is M, O, K, E, Y. M is 3, O is 4, K is 5, E is 4, Y is 3. So let's sort this into less to higher, or let's sort to lowest to highest. So first is K, next is O, next E, M, and Y. So 5, 4, 4, 3, 3. So let's do frequent in the transaction based on this sort frequent. So first is K, next is O, next is E, next is M, and lastly is Y. In second transaction, let's first is K, second is O, third is E, and last is Y. In third transaction, let's do E, let's do K, E, and M. In fourth transaction, let's do K, M, and Y. In fifth transaction, let's do K, O, E, let's do K, O, O, and E. So let's construct FP3 based on these frequent items. So FP3. Let's do first connect this 5K. That's a 5K, so K is 5. And second, let's do another connect O to third one. So let's do O. O is 3. E is 1. Also M. Next, the next connection of OO is E. So let's connect another E. E is 2. Then while this one is connected by O1. Then lastly the connection of E is M and Y. So let's contribute its 2. M and Y. So the connection of M as another to Y, 1. So O, the connection of O is lastly E. Then lastly, Then the key EM must be connected there and here. Then the KMY put here. So this is the FP3 based on this frequency.